I want to go back to one thing that we did last time. We wrote this function called crawl that would go through all the files and directories on your hard drive and print them out with indentation. And I got a really good question after class that reminded me something I forgot to say. The question was, wait, there's a for loop right here. And I thought when we do recursion, we don't usually do for loops. I thought usually Marty says you're not allowed to have a for loop, but here I had one. So like, did I cheat? Was I breaking my own rules? Should I have used a recursive call instead of a for loop here? And what I said is, what I wanted to say to you guys is that in this particular problem, in the description of the problem, I didn't say for loops were illegal. But I mean, I guess there's more to it than just that. What I want to say is that we're using both loops and recursion here. Because we're having crawl, which calls crawl, right? So it is a recursive function, but we're doing a loop for part of it. And so it's not that loops are always illegal when you do recursion. Sometimes they go well together. And I guess the way I would describe it is the iterative parts of the problem you solve using a loop, and the self-similar parts of the problem you solve using recursion. For this part, instead of using a for loop, you could have somehow used recursion for this, but it's easier to do it this way using a loop, and it makes more sense. It's more natural. But the part about folders inside of folders inside of folders, that's actually pretty nasty to solve using a loop. Recursion is actually a much cleaner way of doing that. So I just wanted to show you that this example kind of illustrates that both of these approaches are OK, and sometimes you can use them together. Now, occasionally I'll give you a problem, and I'll say no loops. So sometimes I will still demand that you do a certain thing or not a certain other thing. But it's not the case that you never see these things together. That's all I wanted to say about that. Now, to go on to another type of example, I want to talk about fractals. This is from our slides from Wednesday. I didn't reach it on the last lecture. A fractal is a self-similar graphical figure that's usually drawn using some sort of mathematical function, some sort of self-similar mathematical function. And you guys have probably seen these before or maybe heard of them before. Some of the simpler fractals are just shapes with smaller occurrences of the same shape. You have a square, and maybe you have a square with smaller squares inside of it. And the more smaller squares you chop it up into, you start getting different figures. You have a triangle, and then you sort of pinch out the middle of the three sides of the triangle, and you get a star. Now you sort of pinch out the middle of all those sides, and you get this more and more complicated thing, which they call a snowflake. You have this, which you probably think of as the Zelda Triforce, right? It's also called the Sierpinski triangle fractal, which Nintendo didn't know, I guess. But that's an example of triangles and smaller triangles. And some of these figures get really neat looking, and you can draw them with colors and all kinds of things, and they're really fun. And it's just a beautiful thing, I think. You can write a very small piece of code and produce this really neat pattern. And again, the whole idea is that it's self-similar. Triangles with smaller triangles. You're describing the same figure. So here are a few more examples. You might have seen this one, the Mandelbrot set. That's a pretty cool fractal, and so on. Sierpinski triangle, I'm going to ask you to write that on your third homework assignment. So that's a triangle with smaller triangles. The Koch snowflake looks like that. I want to write one with you guys in a second. I wanted to mention fractals aren't just some math thing. A lot of natural phenomena have patterns that are basically self-similar in nature, and you could describe them as fractal patterns. And here are some examples here. Clouds sometimes have that pattern, mountain ranges, real snowflakes, etc. It happens all over the place. Little crystals, if you zoom in on them, they sometimes have this self-similar structure to them. Now, if you're going to write a fractal as code, usually what you do is you have some sort of parameter indicating where to draw the figure, like x, y, maybe a parameter for how big to draw it. And usually we talk about levels of a fractal. And every fractal has some sort of simplest level, like this is an example of the Koch snowflake. Maybe the simplest level of that fractal is level 1. It looks like that. Level 2 is where you pinch each side out once. It looks like that. Level 3, you pinch each side out again. It looks like that. Now, you might say, I don't really see the self-similar nature here. You know, how do I code that with recursion? Well, I think you start with one that's a little simpler. You don't start with this snowflake, because I think this one's a little tricky to picture. Now, you see my little Socrative icon. I want to show you an example piece of code that draws a fractal. And I want to see if you can trace through it and tell me kind of what it does. So let's do a Socrative question together. If you're not signed in yet, then you can sign in again at the end, but go ahead and you can vote anyway. So here comes a multiple choice. Now take a look at this. I call it the box fractal. I stole this from my buddy Cynthia Lee, who works in our department. Now, see that fractal? It's squares with other smaller squares nearby. And understand that when you draw things, if you draw shape number 1 and then draw shape number 2, then shape number 2 sort of sits on top. Okay, the later shapes are drawn on top. With that in mind, where do I insert that blue line in this code to make it so that the picture will look like that? Take a look. Give me a vote. Please feel free to discuss with someone if you like. A couple more seconds. Take a look. A lot of you have voted already. If you haven't voted, go ahead and cast that right now. Let's take a look and see what the majority of you guys are voting for. By the way, there's a typo, right? Shouldn't it be gw.drawRect? Okay, whatever. So if you chose F, compiler error, I would accept that. There's no F button, though. You guys like C the most. So let's see. Do I agree? I mean, I guess the way I would think of it is if you draw another fractal at a smaller x and a smaller y, then that's going to be this one up here, right? This entire chunk. And then B, I guess the thing under the B, x added and y added, that's going to be this chunk over here, right? And so if I draw both of those fully before I draw the window, which would be myself drawing my own rectangle right here, then those two subfigures would be underneath me, right? Because I would draw them before I draw me. And then the last two, x plus and y minus, that's going to be x plus, y minus, that's this one. And then the other one, x minus, y plus, that's going to be here. So these two are going to be sort of on top of me. I think just that is enough to have an intuition that probably C is the right place to put it. I mean, I think where it gets a little tricky is like, wait, what about the even teenier rectangles, right? How do they decide? Well, just in the same way that this guy has his bottom left and top right on top of him, similarly, this little one has its bottom left and its top right on top of him, and its top left and bottom right underneath it. Do you understand? So it's self-similar in that way. So I think C is the right answer here. Anyway, it takes a little while to get used to fractals and using recursion to draw graphics. I want to do a fractal with you guys called the Cantor set. And it's just a very simple fractal. That's why we're going to do it. You draw a line, and then that's level 1. And then level 2 is you draw the first third and the last third of the same line. And then same thing, you draw the first third and the last third of that line for level 3, and the first third and last third of that line for level 4. Do you understand? And that's kind of how it's self-similar. So I want to write that with you guys, and I want to go to Qt Creator. Let's see, I think I need to reopen, yeah, here. Fractal. I hope I deleted the code. Do I still have a solution in here? Uh-oh, don't look. There, main. So we want to do a Cantor set. Now, I haven't talked at all about drawing graphics in this class. So you're like, I can't do this. But it's OK. Like, we're not going to be doing anything complicated. The only command we need is that you can tell a window to draw a line from one point to another point. That's the only drawing command that we are going to use. So let's not get too hung up on graphics here. We're mostly just thinking about recursion, right? So back here, when it says to draw a Cantor set at x50, y50, size or length 700, and it says to do 6 levels of it. So, OK, here's the Cantor set function. It takes the window, the x, y, the length in pixels, and the number of levels. Now, when we do recursion code, what's the first thing we usually start with or think about? Probably write a base case or try to split up what would be a basic case and what would be a tricky case, right? OK, so if something, then that's the base case. And some people ask me in the past, like, why do I write it this way? Well, I'm trying to build a pattern. Like almost every recursion function, you could start out by thinking about it this way, right? So, OK, what is a Cantor set figure that is pretty easy to draw? What level of figure?
0.
Level 1? Oh, level 0? That's interesting. Level 0 is probably just nothing, right? Yeah, maybe. OK, that's an interesting comment. Let's come back to that. I want to time out that comment. Maybe that would come up later. But OK, so if the level is 1, that's pretty easy. They want me to start here, and they want the line to be this long. So, I mean, I just have to like draw a line across that area. You know what I mean? So like window dot draw line x, y, and then it asks for the finishing x and y coordinates, the horizontal line. So the second x coordinate is what? X plus the length, and the y is the same y because it didn't go down. It's just horizontal, right? So that's pretty easy. Just let me compile that real quick. Oh, multiple mains. That's because my other file has a main, I think. Main. There. OK. Compile and run. And hey, where's my Cantor set? Wait, did I forget something? Window.draw line. Oh, well. Sorry. Like, it's amazing how in the same day you can feel really accomplished and then kind of dumb in the same day. Do you understand why I didn't see anything? I mean, I passed 6, right? I didn't pass 1. So it went to here, and that doesn't do anything. So, I don't know. I thought it would just draw the one line, and that would be a start. But 1 is not equal to 6, apparently. So it didn't do that. OK. Well, but I guess what I mean is I could have passed 1, and then it would have drawn a line. Yes. OK. I did something. I did it. OK. All right. It's going very well. OK. So, but if it were like level 3 or 2 or something, that's trickier, right? That's more of a recursive case. Now, if you look at what it's supposed to draw, it looks like that. And basically, the idea is you're chopping out the middle third and drawing the first third and the last third, right? So, but that's hard. I mean, you could do that maybe a little, but I don't want to draw all of these thingies hanging down here, right? That sounds hard. So, of course, the idea with recursion that I'll say over and over is we will have our code, do a little bit of the work, right? Break off a chunk, and we will handle that chunk, and then recursion magic will handle all of the other chunks, right? So what is the chunk unit here? How much can we handle? What? Anybody have an idea? Raise your hand. I see you. I called you once. I want to see if I get somebody else. What do you think?
Drawing a single level?
Do a level. Okay, sure. You might have thought, well, I'll draw a single line. But I think conceptually, like a level is a good, I like that. I think that's a good chunk. Okay, so, how do I break off a level? Well, maybe we should also ask ourselves, what is the self-similarity here? How is drawing a Cantor set related to drawing a Cantor set? Can you tell me what the self-similarity is in this figure? I mean, I know it's like repeated stuff, but I mean, I want you to tell me a sentence where you say, Cantor sets have Cantor sets in them or something like that. You know, like. What do you say?
I think for each level, you have like 2 Cantor sets, one on the left and the other on the right.
That's a great observation. So she said that for each side, I have like a whole Cantor set over here, and then I have another Cantor set over here. So a level, I don't know what this one is, like level 6 or 7 or something. Let's say it's level 7. A level 7 Cantor set is a line with a level 6 Cantor set underneath it on the left and a level 6 Cantor set underneath it on the right. Right? That's the self-similarity. That's just what you said. That's a great comment. So I think the idea is if we are drawing a level 7 Cantor set or level 3 or whatever, you might be thinking, OK, I'm going to break off a single level. Do I break off the top level or the bottom level? Which one do I handle? Well, we are all very, very lazy people as computer scientists, right? So what's easier to draw, this or all of these thingies, right? I think this one's more easy to draw. So if it's not a level 1 Cantor set, then what I'll do is I will handle the first level, and recursion magic will handle the rest. Okay? So the first level is pretty easy. The first level is just this part, right? So I'll just do that still. Now, of course, whenever you have the same code in the if and in the else, maybe we want to fix that. But OK, just for now, we'll do the same thing. We'll still draw the line. But now we need to draw those other parts, right, using recursion magic. Now, those parts are not the same as me. Like, I mean, I could say Cantor set. I'm going to probably do Cantor set twice, once for the left and once for the right. But I have to pass in the right parameters there for that to work, right? So what's different from me, this is me, versus this left part, which is him? What parameters change? Somebody raise your hand and just tell me like what you would pass here. So what if we do the left one? Is the x the same or different for the left one? I think it's the same x. What about the y? If I'm drawing this stuff over here, he starts right here, which is a little bit lower than me, right? So I think in my spec for this, it says like place 20 pixels of space between the levels. So, OK, so maybe it's my y plus 20 for the next guy. What's his length? His length, just to be really clear, where is it? His length is the length of this thing. You understand? Which is like my x is right here, and my length is all the way to over here. And so for him, it's a third of that length, right? So it's my length over 3 And what are his number of levels relative to mine? It's my number minus 1. If I'm a level 6 counter set, then there's a level, what did I say? If I'm a level 7 counter set, he's a level 6 and he's a level 6. And the one on the right is pretty similar. The big difference is the x coordinate, right? The one on the right is over there. Where does he start? What do you say? Yeah. X plus 2/3 of my length. Right, exactly right. So x plus 2 times length over 3. If I do 2 over 3 times length, 2 over 3 is 0. So this avoids int division bugs. Yeah. Let's try it. I said I was drawing counter set level 3, and I think I have that. I mean, it doesn't look like the slide because the slide is like level 7 or something. I'll try that next. So let's try level 7. And run. Cool. There it is. It's kind of hard to see when it gets way down there. We get so small that we can't really see the little pixels anymore. But that's the counter set. Now, if you wanted to make the code a little bit prettier, I'll come back to the fact that I did this and I did this, right? OK, so I guess I could pull these out. I could pull this out to there and just not. Like, I'll always draw mine. And then if I'm level 1, I don't need to do any more. So maybe what I'll do is I'll say, if the level's greater than 1, then I need to do more work, something like that, you know? But some people were saying before, like, a really easy counter set to draw is counter set 0. So what I like to do is I like to say, if the levels are greater than 0, I need to draw my line and then recursively do the rest. And if I'm level 1 and it's just me and then I make 2 subcalls of level 0, those subcalls do nothing. And so I like this version of the code the best. So I actually like what you said about level 0. So the else here is like, else it's level 0 and we do nothing. So the base case is technically level 0 and we don't have any code for it. It's an implicit base case. And the if guards the recursive case. So even though we don't have if else, it still is using that same concept here to split the 2 cases apart. OK, so there's the code. And why is this better? I mean, I like having draw a line in only one place. And one reason I like it, bless you, is because like if I wanted the line to be a little thicker, I could draw the same line over again with y plus 1 as the coordinates. And that'll just draw a line that's 2 pixels thick. So like if I do that, I think the counter set looks a little bit prettier. It's thicker now. So I can just make that change once, and then I don't have to change it twice, right? So I like that one better. Just bold. I hit the bold, the Control B on my counter set. OK, so that's a fractal. That's just a simple example of a fractal. Now, you know, usually it ends up you have to figure out some kind of coordinates like this times this plus that, this minus 1. That's kind of what you have to do. You have to kind of think about it. Where would that pixel be? Where would that coordinate be? And you fiddle with it a little bit. Now, one thing that surprises some people is when they're doing this, the order of what the code is doing. So I'm going to ask you a Socrative about that, too. This one might be a little quicker than the last Socrative. Let me do new multiple choice. OK, so here's a new one. And I don't know if this will make sense. So let me try to like explain what I mean by this question. So that's basically the code we wrote. Draw a line, and then do the left, and then do the right. That's the code that we just ended up with. OK? What if I put in this line here into our code? That line is a pause command. So in other words, what will happen, you know, when I ran it before, it appeared with all the lines on it. But if I say pause, then what will happen is it'll draw one line, it'll wait, it'll draw another line, it'll wait, it'll draw another line. And what the effect of that will be is we will be able to see what order it draws each of the many lines of the figure. And so my question is, what order does it draw them in? Does it start at the top and draw that across, and then draw this, and then draw this, and then draw 1, 2, 3, 4, and then 1, 2, 3, 4, 5? Does it go left to right, top to bottom? That's A. Does it go here, and then up and down here, and then up and down like that? Kind of snaky like that? Wait, I don't even know what all these arrows mean. D means does it start on the right and go to the left? I guess the thing I want to try to disambiguate is what the hell is the difference between B and C? I think the idea with the difference between B and C is like What is the difference between B and C? I know I meant something when I did this. Wait, let me look at this again. Next thing, you're going to tell me 1 doesn't equal 6. I know I meant something here.
One of the B seems to start at the top levels where C starts at the bottom levels.
Yes,
I don't know
thank
if
you.
exact
It's the start point. Thanks. Hey, you try being 35. It sucks. Being 35 is just like being 19, except everything hurts and is sad and bad. It's like you feel and your brain works like an 80-year-old, but you still sort of look like you're not an old person yet, and so nobody feels sorry for you yet. That's my life, okay? Let's just move on. Yes, you're right, sir. Thank you for helping me. B starts up here and goes through. C starts down at the bottom and weaves its way up. And so it's going to start at the bottom. So sorry for making a difficult explanation of that. Which of these do you think is most similar to the order in which these lines will appear if I ran this paused version of the code? Give me a vote. Let me know what you think. Couple more seconds, and then we'll look at the votes. All right, let's see what you guys think. You guys like, wait, 0? No. That can't be. Oh, there we go. Okay, more people like B, but C got a lot of votes too. So one of my weird-looking ziggity-zag ones seems to be the most popular. Well, hey, let's just go find out. Let's see what it is. So let's go back to the code. And I think what I did was I put a pause before the window draw line. Pause 250. Place your bets now. Here goes. Ooh, see that? So I think that's B, right? I can't remember what I drew anymore, but I think that those of you who voted B, I think that's the right answer. So, I mean, it's hard to have good instincts for what order things happen when you're looking at recursion because it's so deeply nested and it's all over the place. But I think the way you should think of it is it draws all the left before it draws all the right. You know, that's one way of thinking of it. If you look at the code basically says, draw myself, draw the biggest line, then draw all the left side stuff, then draw all the right side stuff. So if the left side has a whole bunch of lines, it will draw all of those lines before even beginning to draw any of the stuff on the right side. So that kind of eliminates things like A or whatever. Now, the slide, the Socrative slide says, how would I change it? Like if I wanted it to do some of these other versions. Well, I mean, you can't, it's not easy to make it print in an arbitrary order, but I just wanted to point out, like, if you did the left part and then the right part and then draw yourself, the end result will be the same, but you will see a different animation that way. And that's kind of interesting to watch. So let's do that. That one starts at the bottom and grows. And of course, when we're done, we're going to have the same thing, but it draws the left, and then it draws all the right, and then it draws what goes on top. And that happens all the way up the stack. So I think moving those lines around and watching it draw is a good way to kind of visually see the recursive calls in order. Okay. So I think that was choice C. If the window.drawLine call had been here, choice C would have been right, I think. Okay. Anyway, oops, we're not done. But any questions about fractals or about the Cantor set or any of the code we wrote so far?